Hi there guys, and welcome to question 1 on this differentiation mixed exercise. Now this is what we're given in the question, and we're told that x is more than 0, and that makes sense because x is the denominator. If that's 0, it kind of creates an infinite problem. Now A, we're asked to find the value of x and the value of y when dy by dx is 0. So that suggests we should find dy by dx. Now we can't do it straight away. Some of you might be happy to do this in your head, but I'm not. I like to write these things down. So x to the 3 over 2. What I'm doing is I'm going to change this into this form here. Okay, so that's 48 times 1 over x, which is 48 times x to the minus 1. Okay, so let's differentiate. So dy by dx, and that's going to be 3/2 of x to the 1/2 if we take away 1, minus 48 x to the minus 2. And we've got to put this equal to 0. So I could change this to square roots, but I'm not going to. Quite often it's better to leave it in this form, but I'm definitely going to change this one here. So dy by dx is, I'm just going to rewrite this term here, so 3/2 of x to the half minus 48 over x squared. And what I should have done is I'll put that equal to 0 here. That's fine. Okay, so let's solve it, and let's see if we can find the values of x and therefore use those to find the values of y in our original equation. Okay, I'm just going to actually rewrite this one just to show you something. So instead of writing 3/2, if I write it like this, it's just going to make the explanation a bit easier. It's a bit easier for everyone to understand. So we could make these a common denominator and subtract these, or you can do what I'm about to do now and remove them using multiplication. So let's start with this 2. If I want to remove this dividing by 2, I have to times everything, this whole equation, every single term, all 3 terms here, by 2. So, which would mean this first bit here, that would just be 3x to the half. We're times in this term by 2, so that's going to be 96 over x squared, and that's going to be just still 0. If we do the same here with the x squared, what I'm actually going to have is, and I'll put it up here, so it's going to be 3x. However, we're now multiplying the same base value, so we can add these powers. So 2 plus 1/2 is 2.5, or 5 over 2. That leaves us with minus 96 is equal to 0. Okay, so let's do some rearranging. If we add the 96 and divide by 3, we're going to get x to the 5 over 2 is equal to 32. And now you have to start thinking. Okay, let's think about what this 5 over 2 means. Well, I know that the bottom number is the root value, so that means that. I know this numerator is going to be its power value, and I know that's equal to 32, which suggests that this in the bracket to the power of 5 is 32. And I know that 2 to the power of 5 is 32. So the square root of x, therefore, must be 2. So if something square rooted is 2, well, x must be 4. Okay, so is that one done? So now we've got to find what y is. So we're given y here. I'm just going to fill this in just next to this question here. So y is going to be equal to 4 to the 3 over 2 plus the 48 over the 4. Okay, so square root of 4, 2, cubed, 8, 48 divided by 4 is 12, and we get 20. So y is equal to 20. So that's part A done. Let's move on to part B. So I'm just going to draw a line down here to separate the two questions. Okay, so we've now got to show that this is a minimum point. So before I go any further, just remember that a minimum point looks like this on a graph, and we're going to have, at any point here, we're going to have negative gradients. When we reach this stationary point here, that's flat, that's zero gradient. And then after, as we go through this minimum point, it's going to be, at any point here, the gradients dy by dx will be positive. Okay? Now, so when we do this, what we're looking for is a positive number to show that the gradient is increasing. We've got two choices to prove the minimum or the maximum. We can, so I'm going to write option 1. And that's drawing a table. So let's take x, and we'll look at the gradient. So that's dy by dx. And if we said x was, where is it? 4. Okay, so if x is 4, let's test either side of it as well. And if we test either side, we'll get to know this picture, whether it's a negative or positive. And because it's a minimum, we're expecting 3 to be negative and 5 to be positive. We do know that when dy by dx is 0, x was 4. So we know that's flat. Okay, now looking ahead, I can see this is going to be a bit problematic, because what is dy by dx when x is 3? Which means we've got to put 3 into here. Now, 3 isn't easy to square root, so, and nor's 5. So I'm not actually going to use this method. I'm not going to go any further, because at this example is pretty tough. So that's why it's good to know both. Well, you must know both. It's essential that you know both of these. So option 2 is when we find the second derivative. So d2y by dx squared. So let's differentiate this again. Okay, so I'm going to use it in this form because it's in the form that I want it to be in, so I can differentiate it easy. So 1/2 times 3/2, well, that's going to be 3/4 of x. And let's take 1 away from this half, so we get minus a half. Minus 48 times minus 2, that's a positive 96. And now we're going to have a minus 3 there. Okay, I'm going to have to substitute something in, so let's rewrite all this. So x to the minus half, that's 1 over the square root of x. So we're going to have 3 over 4 root x plus 96 over x cubed. Okay, so this is the one we're interested in when x is 4. Okay, so when x is 4, what does this equal? So d2y by dx squared is equal to 3 over 4 root 4 plus 96 over 4 cubed. Okay, so at this point you can use your calculator. You're going to want to use it for this bit. And you type all that in, and you'll see you get a positive number. Okay, so even without typing it in, you can say, well, that's going to be 8 on the bottom, so 3/8 plus something more than 1 is going to be positive. It's going to be more than 0, which means after this stationary point, we know that it's 0 here. We've proven that. And now we're seeing that this gradient is improving. The second derivative shows us it's more than 0. So we're going up, the gradient's increasing, therefore it's a minimum point. So therefore it is minimum. We've shown that the second derivative is greater than 0.